Okay, so let's talk about logic gates today. Logic gates are nothing but some electronic circuits, okay? But they are logic in nature, meaning that we will not see the inside of the circuit, we just can see its symbol. We will give some inputs, and when we give those inputs, it will give us some output. So there are three basic logic gates that we will talk about first. So the first logic gate that we will talk about today is let's start with three logic gates first. First logic gate is the OR gate. These are the basic gates. Okay, these are the basic logic gates. Second is an AND gate. And the third logic gate that we will talk about is the NOT gate. Okay. There are three other gates which are derived from these gates. Means using the combination of these three gates, there will be some other gates which will be formed. Those gates are the fourth gate, which we can talk about, is the NAND gate. There is a NOR gate. And there is an XOR gate. Okay. So let's get started first with the OR gate. So first let's talk about the OR gate. So let's write it down. Now, first of all these gates will have some symbol. Okay. So what is the symbol of an OR gate? So let's draw the symbol of this OR gate. The symbol of an OR gate is like a semicircle like this. It's a beautiful gate. And okay. So now this will have, the gates will have some inputs, and with it, for those inputs, there will be some output. Okay. So now let's denote the inputs. So I will write input as A and B, and the output, I'm denoting it as Y. Okay. So A and B is the input to this OR gate, and there will be some corresponding Y for the combination of the inputs. So do we have something which will give us the combinations of input and what will be the corresponding output? So the answer is yes. There is something known as the truth table. Okay. So there is something which is known as the truth table. Truth table is a table which will let us know what are the possible inputs that can be given to this gate and what will be the corresponding output for those combinations of inputs. Okay, so A and B are nothing but the input and Y is nothing but the output. So let's see. Now, as we know that there are two inputs, so number of inputs is 2. Okay. Now, how many possible combinations can I write over here? And I don't want to miss any combination. So how to go about it? So when we have two inputs, then the base of binary is 2 as discussed. So 2 is the base. And how many inputs are there? So this formula is 2 raised to n. So 2 raised to n is number of inputs. So 2 raised to 2. So there are possible 4 combinations of inputs are possible. And for that, we have to give the corresponding output. Now, which 4 combinations of input do we have? Now, we don't want to repeat any input, okay? So, for doing that, for not repeating the input, what we can do is, you start with the B over here and start writing 0, 1, 0, 1. You will write this 4 times because you want 4 possible combinations. So, alternatively write 0, 1, 0, 1. And in the A, you double that up. So write double 0 and then write double 1. In this way, we will make sure that none of the input is repeated and we have all the 4 combinations of the input. Now, what will be the corresponding output? So here, we know that this is an OR gate. OR means A or B. A or B. If any of this is present, the output is present. Okay. So if both are absent, 0 means absent, 1 is present. Okay. So if both are absent, if 0, 0 means both are absent, then the output is also absent. But if one of them is present, here the B is present, even though A is absent. So if any one of this is present, the output is present. Any one of this is present, output is present. Here A is present, so the output is present. And here both are present, then in that case also the output is present. So this is the corresponding output for this combination of the inputs. Now, suppose I want to write this in the form of an equation. So how do I represent the same thing in the form of an equation? The equation looks something like this. The output y, which is the output, is equal to A or B. Now here you can see this plus sign is nothing but a representation of OR. So you can also write this as y is equal to A or B. Now the question is, can we write this in a statement format? The answer is yes. We can also mention this in the statement format. What will be the statement format for this? The statement format for this will be the output means you can say if any input is 1, means if any of the input is 1, like here, if any of the input is 1, what is the output? The output is 1. So if any input is 1, the output is 1. Or you can alternatively write this as if all inputs are 0, if all inputs are 0, so as you can see, if all the inputs are 0, the output is 0. So this is how you will write the statement. Now, can we have more than 2 inputs in the OR gate? The answer is yes. You can have a 3-input OR gate, 4-input OR gate, and so on. So what happens if we have a 3-input OR gate? So let's draw the symbol for the 3-input OR gate. Okay. So how does the symbol go for the 3-input OR gate? I'm just going to take this. We're just going to draw this beautiful OR gate with 3 inputs. 1, 2, 3. And we can write that as A, B, and C. And sometimes you will see that they represent output as X. Anything is fine. You just can label it whatever you want. Now, as you can see, every logic gate can have 1 or more than 1 input. But if you see here, also you have just 1 output. Over here also you can see it can have only 1 output. So there can be more than 1 input, but the output is always 1. Now, what about the combinations? So now you may understand again here n is 3, which is number of inputs is 3. And our formula says 2 raised to n combinations are possible. So 2 raised to n will give us 2 raised to 3, where n is equal to 3, which is equal to 2 2s are 4, 2s are 8. 8 combinations are there. Now, you might have trouble finding whether 8 combinations, how to write those 8 combinations without repeating any combination. So there is a trick for that. Let's see the trick. A, B, C are inputs. And right here, we'll write X as the output because as I've mentioned here is X. So I have to write X as the output. Okay. So let's now write down all the combinations of the inputs where we are not going to repeat anyone, right? So with this, now this C is the last one, which is in the units place. So this is 2 raised to 0. Okay. So what we will do is we will continue writing 0 followed by 1, followed by 0, followed by 1. Now how far do I need to go with this? So there are 8 combinations. So I need to write this 1, 2, 3, 4, 5, 6, 7, 8. We need to write it till we get 8. Okay. Now this is doubling up. So now we'll start always with a 0, don't forget. So we'll start doubling up, double 0, followed by double 1, followed by double 0, followed by double 1. Great. And now double that up again. So what will it be? So now this will be 1, 2, 3, 4 times 0, followed by 4 times 1. Now we see that none of these combinations are repeated and they are all unique. Okay, so now as we have seen here, if all inputs are 0, the output is 0. This is the statement that we have written and we have to follow this statement. So if all the inputs are 0, is all the inputs 0? The answer is yes, then the output is 0. Do we have a 1 over here? Yes, then the output is 1. And similarly 1 over here, so the output is 1. Oh, 2 ones, bonus 1. Only 1, 1, no problem. Okay, cool. Again, and here also 1. So this is the output of a 3-input OR gate. Okay. So now if you can try, okay, how do we write the equation for this? Let's see first that, and then we will try something else. So the equation will be y is equal to A or B or C. I hope that is clear. Instead of y, we have to write x, my bad, because we have written here x. And now I want everybody to try forming a 4-input OR gate. 4-input OR gate. This is the homework. Okay. Now, the second gate that we want to talk about is the AND gate. Let's talk about the AND gate. Okay. So that is the second basic gate, which is the AND gate. Now, as you can see that this is D. So the symbol will be like a D. Okay. And I will draw again 2 inputs. We can go for more than 2 inputs also. And I will have one output over here as Y. So this symbol, this is the symbol of an AND gate. Okay. Now, when this symbol, again, we will write a truth table. We will find out that what all combinations of input can I give to this and find the corresponding output to that. So let's write it down quickly. So write it down A, B, and Y. A and B are the inputs, Y is the output. Now, as we have discussed earlier, we start with B and we know that N is equal to 2. So 2 raised to N, which is equal to 2 square, which is equal to 4 combinations. So now let's start with B. Here we go from 0 followed by 1, 0 followed by 1, 1, 2, 3, 4. Okay, we have written it 4 times and not 4 times. And then we have to follow it by double 0, double it up and double 1. Now, this is an AND. So A and B both have to be present to get an output. Now here, present means 1, absent means 0, as we have discussed. So both are absent. So if both are absent, then absolutely there is no answer. That is a 0. 1 is present, will not do. Both have to be present. So again, this will be a 0. Again, B is absent. So this is a 0. But A and B both are present. Then the answer is 1. So both have to be present for the answer to be generated. Now, this is the truth table, which has given us all the possible combinations of input and the corresponding output, which is the function of a truth table. Now, let us write the equation. Now, what can be the equation for this? So, let's write it down. Equation Y is equal to, what is Y? A and B. This dot representation is for AND. Okay. So it's like a multiplication, but it is not. It is an AND gate symbol in equation format. Now, can we write a statement about it? Yes. Let's write a statement about it. What can we write about this gate? So as you can see, if any input is 0, the output is 0. So we can write if any input is 0, the output is 0. Or you can write, if all inputs are 1, the output is 1. Any which ways, you can write this statement. And this is the second gate, which is a AND gate. So your homework can be to draw 3 and 4 input AND gates. Okay. Now, let's go with the last gate, which is the last basic gate actually. And that gate, which we will talk about, is the NOT gate. Now, this is the only gate which has only one input. This gate can never have more than one input. So the symbol of this gate will have only one input. I'm drawing its symbol over here. It has got only one input, which is A. It has a triangle and a bubble. This bubble is actually the negation. So A, and the output will be Y or X or whatever you want to name this as. You can name it. Now the truth table for this will be pretty simple because there is only one input. So 2 raised to 1, which is equal to 2. So there are only two combinations. So let's write A and Y over here. So the two combinations can be 0 or 1. And the Y will be not A. Not A means what? Not 0. If not 0, then there is only one option. That is 1. Because it is binary, we just have two numbers, 0 and 1. So if it is not 0, then it is 1. And if it is not 1, then it is 0. So this is the truth table for the NOT. This is the symbol for the NOT gate. And what about the equation? Equation for the NOT gate will be Y is equal to not A. This bar represents negation. Negation means output is not input. Or we can write that as in the statement, the output is not input. Okay, the output is not input. So this is the last gate that we had to talk about, which is the basic gate, which is a NOT gate. All the other gates that we are going to look into are a combination of these three gates. Okay, so NAND gate, NOR gate, and XOR gate are the combinations of these three gates. I hope that is clear. Thank you.